Hello everyone, this is the North America Math Contest Go Go Go. This week we are going to work on how to solve magic cube. Magic square. So before we start, we need to define what a magic square is. A magic square of n times n means given a magic square of n times n, right? We want each row, each column, and each diagonal, like only those two diagonals, to have the same sum. And the numbers that fill the magic square must be in the range from 1 to n times n, and each number can only be used once. It may seem complicated, so I'm going to give you one more example. So, this is a magic square because it fulfills. Each line have the sum of 15, including diagonals. And the numbers are in the range of 1 to 3 to the power of 2. And each number used exactly once. So this is a magic square. Bruh. Now we need to talk about how to calculate. Have discussed previously about what a magic cube is, bruh. What a magic cube is. Magic square is. Now we are going to determine how to calculate the sum of each line of the magic square. I'm going to give you the formula. The formula is sum of numbers where n square is the length of the magic square divides by n. So let's use 4 times 4 as an example. So a 4 times 4 means that the number is from 1 to 16. And each number can be only used once. So no matter how we place the number from 1 to 16, the sum of those numbers is definitely going to be 1 plus 2 plus 3 until to 16, which is going to be 17 times 6, 17 times 8 is going to be 136. And then it has 4 lines. So no matter how we place 1 to 16, the sum is going to be fixed, it's 136. And then the number of lines is also going to be fixed, which those 4 are. Then we divide it by 4, which we get 34. So this is why this formula works. The sum of the numbers from 1 to n squared, the sum, not the number, divided by n is going to be the sum of each line of the magic cube. magic square. Now, let's talk about a common method. Let's talk about a common method that can solve all magic square with side length, with side length of an odd number. We are going to define some terms first. This is called a row. This is called a column. This is called a coordinate, which its form is in row, column. We are then going to define two vectors. Vector 1. Starting vector 1 is common vector. Meaning, and it is in -1, 1. This is the vector that we are going to use when the steps is not divisible by 3, not divisible by the side length. Not divisible by the side length of the magic cube. So for example, if there is a magic square of 5 times 5, the common vector will not be used. Will be used when the steps is not divisible by 5. This is called common vector. And the Dn vector is 1, 0. Steps is divisible by 5, divisible by the side length. And then, for the graph, we are going to, for the row and column, we are going to start with 0, not 1. Start with 0, because it's more comfortable for me. Start with 0, not 1, okay? Start with 0. So for example, this is 0, 0. This is row column 0, 1. This is 0, 2. This is 1, 0. This is 1, 1. This is 1, 2, okay? So after we have discussed this, let's begin. We are going to talk about the step. This method is called layers method. It's invented by a French mathematician called Layer around the 18th century, and it is the most common way of solving this type of magic square. Now let's use this way to help us solve it. We first need to set up a starting point. The starting point is strictly determined, which the starting point for 1 is going to be n minus 1 divided by 2 plus 1. So this is the starting point. So this means that the starting point for 3 is going to be 0, 1 for this. For this graph, it's this. So it starts at here, 1. And then let's use the vector to help us determine the vector for it, since it is not divisible by 3, we add negative 1, 1 here, and we get 2, 2. And then we add up another vector, 2, 2, we add a vector again, it's 1, 3, so it becomes 1, 0. So this is the place for 3. Remember, I will tell you a law here. So if you see negative 1, then you just automatically convert it to n minus 1, which here is 2. If you see n, then you just simply convert it to 0. So 3 will automatically be 0 in this case. So the third point will be here. And then we add up a 1, 0, which is 4 here. And then we add up 1, 1, this is 5. And then we add up negative 1, 1, is 6. And then since 6 is divisible by 3, we do not add up a negative 1, 1, we add up a 1, 0, which is 1 grid down, and then we get here. And then we continue solving that, and we can find the final solution is 8 and 9. So we get a final magic cube for it. So this is the formula of calculating it. Now I'm going to show you the code that can easily solve it. What we need to do is we only need to enter the starting point according to the formula, which for 5 times 5 grid is 0, 3. 0, 2, right? Yeah, 0, 3. And then we set those datas ready. So therefore it becomes a 5 times 5 grid. And this generates every single point for every single number. So this code can help you a lot on calculating it. Yeah. Through this, you can calculate the grid, the one you want. And the starting point, I think I make a mistake. It should be 2, 0, 2. So this is the starting point. And then from it, you can, so this is the correct code. From this, it can generate every single number of it. Yeah. Here we come to the end of our lesson, and I hope you have learned a lot. See you next week.